Aloha and welcome to the Big Island of Hawaii, home of world-famous beautiful beaches, hula dancers, and popular surf culture. What you may not know about the Big Island is that it is also home to big science. From the depths of the ocean teeming with life to the active volcano Kilauea erupting continuously since 1983. The Big Island of Hawaii is filled to the brim with exciting science to explore every single day. The summit of Mauna Kea, the near 14,000-foot mountain on the Big Island, is certainly no exception. Here sits 13 of the most powerful astronomical observatories on Earth. By observing the cosmos with telescopes specialized for different wavelengths of light, the observatories on Mauna Kea are quickly increasing mankind's understanding of the universe and our place within it. How do these telescopes do it? To find out, we'll be spending 24 hours in the life of the NASA Infrared Telescope Facility.
Yeah, it looks pretty good. Just looking at some data that took last month on an object. We'll try and get it again tonight.
Meet Dr. Bobby Buss, one of the brilliant, motivated astronomers that is given the opportunity to use the IRTF. His job is to help solve the unanswered questions of the universe.
Long before I ever go to the telescope, there's a whole process that sometimes takes several months, maybe even as much as a year, where I come up with the experiment and plan out the observations. I have to learn about the telescopes and the instruments that I want to use. In this particular case, I want to use the NASA IRTF because of its ability to cover the infrared wavelength range, and also because it has the right instrument for me, a spectrograph, in order to carry out the observations. The process includes writing a proposal, requesting time on the telescope, where I lay out the specific science goals and justify why I need to use that particular telescope. Once that proposal has been submitted, it is reviewed by a group of astronomers who are knowledgeable about the field, and they rank all the proposals that come in. And if I'm lucky and I'm awarded time, then I am notified and can start to make plans for travel out to Hawaii to use that telescope.
As Bobby is anticipating his upcoming observations, the NASA Infrared Telescope Facility day crew is preparing the telescope. Since telescope observations mostly occur at night, the day crew staff needs to have any potential issues with the telescope attended to during the day.
The first and foremost about the day crew is to make sure we take care of maintenance and operation, to make sure that everything is working okay for the nighttime observation. So with that in mind, we take care of the priorities on the trouble log first. Whether it's an instrument problem, it's a facility problem, whether to do with computers or electronic equipment or something on the telescope, we take care of that first, because that's the number one priority, to make sure that we maintain and the equipment so they can operate that night.
Every day, this remarkable group of hardworking engineers travel from their homes at sea level up to the near 14,000-foot mountain in order to maintain the excellent condition of the telescope.
I start my day at 5:15 when I wake up, and I usually take a jog. It takes me about 5 minutes to get to work from my house. And upon reaching work, I go into the building and check on the trouble log. And then I grab the keys. We usually have a short meeting to see what we're going to be doing for that day, what we're going to pick up before going up, what supplies we need. And then if we need to load stuff in our vehicles, we go load it and start going out and head up to the summit. When we reach our facility, we unload things from the vehicles, and then we start doing what is most important. We start doing that first. If it's a trouble log kind of problem, we do that first before anything else.
The main job is essentially to test the instrument before each new observing group comes in, and which entails taking some flats and some spectral lines to make sure that the instruments are working before we leave.
When you work up here at the observatory, you have a vast amount of things that you have to do. It's not only one thing. You got instruments that you got to maintain. You got electronics that you got to maintain. You got computers that you maintain. You got some electromechanical stuff that you have to maintain, and that's all part of my job description. As far as learning things, I learned a lot up here because it was a lot of on-the-job training and stuff like that you learn by yourself. And over the years, 21 years, you learn a lot of things, just by doing things. Yeah.
One aspect that makes this job very interesting is constant renewal, in a sense that this instrument generally have a lifetime of 6 to 7 years, at which point they essentially become obsolete because of development in detectors and other things. So we periodically get new instruments here, and in my particular case, it typically involves going over to UH Manoa and work with the people that develop and build the instrument to get the knowledge we need to maintain them here for the next 5-6 years. So the job is always renewing itself, and that made us last some 20 years or more up here.
The NASA Infrared Telescope Facility is one of the oldest and smallest telescopes on Mauna Kea, and yet it continues to collect data that is time-critical, accurate, and essential to NASA's mission objectives.
The NASA Infrared Telescope Facility is operated by the Institute for Astronomy for NASA. We get all of our funding from the Planetary Astronomy Program at NASA. We support ground-based observations that are complementary to spacecraft missions. So, for example, we have recently done observations of Mars in support of the Mars Observer spacecraft, and we've made observations of Saturn and the satellite Titan in support of the Cassini spacecraft. And about 50% of the telescope time is dedicated to planetary astronomy. Our telescope is considered a mid-sized telescope. The aperture is 3.0 meters, so it's actually quite big, but compared to the other telescopes on Mauna Kea, it's considered to be a small to mid-sized telescope. One interesting thing to mention is that we can make observations in the daytime, and that's because in the infrared, the sky brightness does not change very much, and so we can observe solar system objects very effectively in the daytime.
As the sun gets lower in the sky and the IRTF day crew begins their journey back to Hilo, a new crew gets ready for the long night ahead.
Okay. head on off. Got everything, and head on out.
Meet Bill Golish, an IRTF telescope operator.
I don't know, a lot of clouds out there.
Bill's been operating the IRTF for 23 years now, and he's become quite adjusted to sleeping in the daytime and the difficulties of staying awake all night at an extremely high elevation. He often works for several nights in a row at the summit and sleeps during the day at Hale Pohaku, the residential facility for Mauna Kea employees. The facilities at Hale Pohaku allow the staff of Mauna Kea's astronomical observatories to eat, sleep, and network with other astronomers. But before sunset each night, the astronomers and telescope operators are gathering their things to head from Hale Pohaku at 9,200 feet to the home of the IRTF at 13,675 feet.
IRTF is one of the first telescopes expressly designed to be infrared optimized, that it's very sensitive in the thermal infrared. And we're also, our main mission is supporting NASA planetary exploration missions. So we have capabilities for following objects like planets and asteroids and comets that don't move at the same rate as stars. And we can also change instruments to look at a variety of wavelengths on short notice, several times an hour.
My particular field of study is asteroids, and I'm using infrared wavelengths in order to learn about their compositions, about their sizes, and other characteristics about these bodies. The particular study that I'm carrying out uses spectra taken at the longer or infrared wavelengths in order to determine things about the composition of a particular set of asteroids. Studying silicate minerals, very common minerals that we can find here on Earth, in particular pyroxenes and olivines. They're very common among the asteroids. By studying these minerals, you can learn a lot about how these asteroids formed and how they have evolved over time since their formation.
As darkness is quickly approaching, Bill prepares the telescope by making sure all of the instruments are at their preferred temperatures.
We have state-of-the-art infrared instrumentation on the telescope. These instruments are the best in the world, and that's what makes a telescope very powerful for planetary observations. So we have cameras and spectrographs that operate at infrared wavelengths. And these instruments are built at our institute at the University of Hawaii. Therefore, in the support of this telescope, we have a large number of very talented people, engineers and technicians, who build and support our instruments, as well as operate the telescope.
Being a telescope operator requires a lot of different job skills that are hard to put on the application. I think you need to be patient with the wide variety of observers that come out here and have some social skills in dealing with them. You need a lot of computer skills for the variety of systems we have up here, and some mechanical skills to get in there and see if you can fix things in the middle of the night, or climb up on the dome, or fix whatever needs fixing, or know that you can't fix it and try and gently wake up somebody in the middle of the night to have them tell you how to fix it.
The shutter for the enclosure opens, clearing the way for the telescope to collect photons.
I'm gonna start working, so. Okay.
So Bobby, we're on a focus star. I've got the specs crosshairs and the specs visual focus, so we should be pretty close to in focus for you.
Okay, good. Okay, let's see if we have an asteroid here. Looks like we have an asteroid. Hot dog. Position is just a little high on the slit, so I'll probably have you recenter the crosshair, Bill, when we get to it.
One of the reasons Mauna Kea is prized as the best astronomical site in the world is due to its calm, clear nights. However, perfect weather for observing is not always the case. In Hawaiian, Mauna Kea means white mountain, because oftentimes this summit is adorned with a thick coat of snow.
The weather conditions can be pretty challenging up here. Sometimes it's so bad that we can't even get up from the dormitories at Halepahaku. Fortunately, nowadays we have computerized sensors that we can read from there to tell if the conditions improve, and then we might need to try and come up in the middle of the night. Other times we're actually up here when the weather gets bad, and we have to keep monitoring it, and if the road starts icing up, then we may have to leave on very short notice, 5 or 10 minutes, to be able to get down safely on the roads, and that's the main condition, is the safety of the people up here. Okay, we're in the low 80s here. You seeing anything outside? Oh yeah, we can see it on the satellite map. All right, let us know if you guys bail, and we'll do the same. Okay, thanks, bye. You, Kurt's at 90% in closing. We're still 83.
Sorry, Doctor. Gotta give it to me right when the weather goes down.
So if you have a highest priority target, let's get to it.
Okay, let's go.
At our telescope, we have remote observing. This means that instead of coming to the telescope, the astronomer can conduct the observations from his or her office on the mainland or from Hilo. And this has been very useful for many people because of the difficulty and expense of coming to Mauna Kea. And also it's very difficult to work at the summit of Mauna Kea. Since the oxygen level is relatively low, it's difficult to work efficiently at this high altitude. And so many astronomers find it very convenient to do their observations remotely from the comfort of their office.
Sorry, John, where did you want to go? HD 62164, is that right?
Yep.
Okay. We're slewing. And I see the stars centering up on the star. Taking the on-axis mirror out. Zeroing the telescope, pointing. And we're there and ready to go, John.
Of course, to keep the NASA Infrared Telescope facility in excellent working order 24 hours a day, it takes a lot more human resources than just the astronomers, telescope operators, and day crew.
Here at the University of Hawaii Institute for Astronomy exists an entire team of specialized individuals dedicated to astronomy excellence. From software engineers to instrument technicians to network systems engineers and administrative personnel, the IRTF staff relies on one another to achieve the goals set before them.
Thanks to the IRTF, I have some wonderful data on a very bright asteroid in the main belt called Vesta. The spectrum that you see here is the near-infrared spectrum of Vesta. It's a special object, really, because of the upcoming spacecraft mission to that object called Dawn, which will be launching fairly soon. We'll be also comparing our information about this asteroid with meteorite data that has been obtained in the laboratory, comparing what we can learn both from the telescope, from the spacecraft, and from our laboratory measurements to try to come up with a more complete story of how Vesta formed and how it played a role and how it's playing a role in us learning more about the formation of the solar system.
As always, the sun does eventually rise, and night operations must cease for a little while, leaving time for the day crew to come up and fix any kinks. Meanwhile, the eyes to our universe sit patiently and wait for the dedicated staff of the IRTF to continue finding secrets that can only be discovered in 24 hours in the life of the NASA Infrared Telescope Facility.
Oh, I just... Thanks anyway.
We make the parts for the mountain. We know what we're doing at all times and never make a mistake. No.
Is certainly no exception. Cool.
Hey, to get my good side.
Looks pretty good.
Oh, no, we don't have.
Okay. All right. The NASA IRTF. Oh, let's start over again.
Okay, I'm gonna go and take this apart. Actually,
That looks good.
don't touch that.
Hey Brian, how's it going, coffee cup? Oh, we have 2 more coffee cups that haven't been deployed yet. Can I ask?
Oftentimes.
Safety goggles are
That's
on.
for the bloopers.